What are hydrogen bonds? An attractive force called a hydrogen bond can exist between certain molecules. These bonds are weaker than ionic or covalent bonds because it takes less energy to break these types of bonds. However, a large number of these bonds going on can exert a strong force. Hydrogen bonds are the result of an unequal charge distribution on a molecule. These molecules are said to be polar. If we look at a water molecule, we can see the oxygen atom shares electrons with two different hydrogen atoms. So, in total, this molecule has 10 protons, 8 from oxygen and 1 each from the hydrogen atoms, and a total of 10 electrons, 2 shared between the oxygen atom and hydrogen atom number 1, and 2 shared between the oxygen atom and hydrogen atom number 2, and the other 6 non-shared electrons from the oxygen atom. So, this water molecule is electrically neutral, but it has a partial positive side, the hydrogen side, and a partial negative side, the oxygen side of the molecule. The electrons are not shared equally within the molecule, as they have a higher probability of being found closer to the nucleus of the oxygen atom, giving that end a slightly negative charge. So the hydrogen atom's end of the molecule will have a slightly positive charge. These charged ends weakly attach the positive end of one water molecule to the negative end of an adjacent water molecule. When water is in liquid form, there are a few hydrogen bonds, solid form, many hydrogen bonds, and when water is steam or gas, there are no bonds because the molecules are too far apart to form any bonds. Hydrogen bonds only form between hydrogen atoms that are covalently bonded to an oxygen, nitrogen, or fluorine atom. Hydrogen bonds are also important in the structure of proteins and nucleic acids, which we will cover in later videos. So now we know that water molecules are polar, or have a slightly positive and slightly negative end. And in fact, many lipids, or fats and oils, are not polar, so their molecules share electrons equally in their bonds. So these are non-polar molecules. This means that when water and oil come together, they do not form bonds with one another. Even when we try to mix them, the water molecules will eventually separate because their polar molecules are attracted to one another and will form hydrogen bonds, which will separate the water and the non-polar oil molecules. And that be the basics on hydrogen bonds.
Okay, hi guys. Assalamualaikum warahmatullahi wabarakatuh. And we are from group on the van der Waals forces. And today we're gonna present on what is van der Waals forces. So before that, this is our group members, and we're gonna present on the topic of van der Waals forces. So before we go any further, we will do a little bit of history check on what is van der Waals forces itself. And for information, the force itself are named after the Dutch physicist named Johannes Diederik van der Waals, who in 1873 the first one to postulate these intermolecular forces and developing a theory to account for the properties of real gases. So the name itself of the van der Waals force are based on a real life person, a Dutch physicist named Johannes Diederik van der Waals. And what is van der Waals itself? What is the conceptual about van der Waals? So van der Waals forces are a weak force that contribute to intermolecular bonding between molecules. Van der Waals force also are the sum of attractive and repulsive electric force between atom and molecules itself, and they are known to rapidly vanish when the distance between the interacting molecule increase, meaning the more the distance, then it will vanish. And when the electron density around the nucleus of an atom undergoes a transient shift, it is common for the van der Waals forces to arise. So we'll go straight into the characteristics of the van der Waals. There are 4 of them, and the properties also have 4. So we'll start by 1. The van der Waals forces, they are weaker compared to either ionic or covalent chemical bonds because they're can be vanished, just like what we said just now, and they are independent of temperature, with the exception of dipole and dipole interactions. They also are more adaptive and cannot be saturated, and they are not directional. And for the properties of van der Waals, as I said before, there are four of them. First is the solubility. There is the lower alcohols are soluble in water because of the hydrogen bonding which can take place between water and alcohol molecule. And there are volatility, as the compound involving hydrogen bonding between different molecules have higher boiling point, so they are less volatile. Viscosity and surface tension. The substance which contain hydrogen bonding exists as an associated molecule, so the flow becomes comparatively difficult. They have higher viscosity and high surface tension, and the lower density of ice than water. In the case of solid ice, the hydrogen bonding gives rise to a cage-like structure of water molecules. And we will go to the application of van der Waals forces.
Okay, we move to the next part, which is application of van der Waals with hydrogen bond. There is four type of example that I will explain to you all. But the first is hydrogen bond in the protein. We can find hydrogen bond in the secondary structure of protein. The hydrogen bond in secondary structure of protein form the shade of the secondary structure of protein, which is it bond between the backbone oxygen and amide hydrogen. When the two strings are joined together by hydrogen bond involving alternating residue on each particular strand, a beta sheet is formed. So there is two kinds of secondary structure of protein that we can find hydrogen bond in our body. Okay, we move to the next part, which is example 2, van der Waals in plastic polymer. Van der Waals bond is really important in plastic polymer compared to another application. Plastic is composed of several different organic molecules. One of particular, we call it polyethylene. Polyethylene is organic polymer that made of several monomers called ethylene molecules. That's the thing that you have to know. But what kind of bond in polyethylene? The polyethylene, the molecule composed of hydrogen and carbon atom in the same ratio as ethylene gas, but there are more instead of atom in the polyethylene molecule. Can you get it? The hydrogen bonding between many monomers of ethylene made the polymer of polyethylene. So as the number of atoms increase in the molecule, the matter passes from gas to liquid and finally to be solid. And we can find of polyethylene compound mostly in high density polyethylene, which is HDPE, and low density polyethylene. That is the second example of van der Waals force. So we move to the next example, which is the third application in our daily life. The third application that we can find in our daily life, which is in our own body, which is double helix DNA. Double helix DNA formed by hydrogen bond between this pair. So this gives DNA a double helix shape and make a replication of the strand possible. So for additional information, the hydrogen bond is useful to the unzip between the pair. That is the third application that we can find. The last application that we can find is hydrogen bonding in single helix. There is 3 applications that we know in our body. So it's really important because it's about our body and we use it every day in our life. The last is hydrogen bonding in single helix. In right-handed helix, the groups such as nitrogen, hydrogen, and carbon double bond to oxygen are vertically adjacent to each other. So this group link each other through hydrogen bonding in such a way a spiral form hydrogen bond with with nitrogen hydrogen of other spiral. So that's all that the application that you must know, because it's really important in our daily life. It is in our body. So I can conclude that there is so many applications of hydrogen bonding, which is use van der Waals force. We must know it, we must learn it, and that's all from our group. Thank you.